we've got in question 10 is it's a reminder of something we did a couple of lessons ago, which was we're talking about the dissociation of water, and we all know, I think, this is just a definition, the value for Kw, it's the concentration of hydrogen ions times the concentration of hydroxide ions. And the one that we're struggling with is this one here. Two or three people asked the same thing. So you have to think about this reaction and think about what's going on when you change the temperature, right? So first of all, you've got to realise this is a bond breaking process. You're breaking the bond between oxygen and hydrogen. So in other words, the forward reaction is endothermic. That's the important thing to realise before you start. The bond breaking, endothermic. And it's an equilibrium reaction, right? So if you increase the temperature, the equilibrium will try to oppose, the position of equilibrium will try to oppose the change made. So if you crank up the temperature, it will, if you like, try to cool down, so the equilibrium will shift to the right. So far so good? Right, so if the equilibrium shifted to the right, that means the concentration of H plus and the concentration of OH minus have both gone up, which means actually Kw goes up and pKw goes down. But it's asking you about the pH, and so we don't have to think about the hydroxide at all. We've just said that if the if the temperature goes up, the concentration of both of these go up. So it's still neutral, but the concentration of hydrogen ions increases. And given that the pH is equal to the minus the log of the hydrogen ion concentration, the pH therefore must have gone down. I'm sure you can explain that in words. It's an endothermic forward reaction, increase the temperature, equilibrium shifts to the right, increasing the concentration of hydrogen ions, thereby decreasing the pH. Okay, now, with that, it doesn't go down by much, it goes down to about 6.5, something like that. And I think in the lesson when I covered this with you, I said, so water at 100 degrees is acidic, right? Because it's got a pH of less than 7, and some of you agreed and some of you didn't agree, but it's not. Neutral pH changes at different temperatures. We've been taught for years that it's pH 7, it's only pH 7 at 25. Okay? Neutral pH is variable. Neutrality is all to do with the fact that you've got the same number of it's the same concentration of both of those substances. Alright. So let's talk a bit about something a little different, which we'll feed into some stuff we're going to do next lesson, a little practical for you next week anyway at some time. We're going to talk about the pH of salts. Now this is, I think slightly difficult and needs a bit of explanation, a bit of patience and a bit of thinking about. People find this kind of tricky, so it's worth spending a moment or two on, worth looking over it again if you're struggling. So there are essentially 3 different types of salts, and salts always come from neutralization reactions. You've known for years you make salts from strong acids and strong alkalis, and you get things like sodium chloride from those, and you also get water when you do the neutralization. So if you take a strong acid and a strong alkali, you get a neutral salt formed. And so all of the salts you get from strong acid, strong alkali reacting together are neutral. So examples are sodium chloride, maybe potassium sulfate. Any salt that comes from a strong acid and strong alkali reacting together is a neutral salt. Now the pH 7 if you chuck it into water. But if you take a weak acid, and we're going to use, I'll use a specific example. I'll use ethanoic acid as an example. If I take a weak acid, ethanoic acid, and react it with sodium hydroxide, the salt I get there, and it's not an equilibrium reaction, it's a one-way reaction, we'd get CH3COO And when I was your age, and I didn't realise this, I got my wrist slapped. It was well after I'd done my degree. I drew a line between the oxygen and the sodium, and a line represents a covalent bond. And we show that as an ionic interaction between there and there, plus H2O. So you all know that stuff. That's a weak acid. So you can think of this in two ways. So the easy way to think about it is to think about the fact this is kind of like a tug of war. You've got a weak acid and a strong alkali. So the salt that's made the strong alkali wins the arm wrestle, right? The tug of war. So this, without even thinking about it, is going to be a slightly basic salt, right? And we can just work that out without really trying too hard, because it's a strong alkali reacting with a weak acid. Okay, but why is it basic is the question you'll be asking your exam, and it's quite a common question. It's also quite a common question to not get the marks for. It's usually worth a couple of marks. To work out why it's basic, we've got to think, well, what makes something alkaline? So what's the substance that makes something alkaline, please? Tell each other. What's that? OH minus. So somehow we're generating OH minus. If we take that salt, or in fact really just the conjugate base of the weak acid, which is that, how are we generating hydroxide? And the answer is the salt actually partially reacts with water. It's a weak base. It partially dissociates water to generate that, and crucially, that stuff. That's what brings the pH up a bit, the generation of hydroxide. Now I know, personally, I found that a little bit awkward to get my head around. Well, hang on a minute, you're making an acid and an alkali here, that's confusing. But remember that pH has nothing to do with the concentration of that directly. It's concentration of H plus or OH minus. That's it. So we're generating hydroxide when this salt reacts with the water solvent. And that's, you've got to be able to explain that. So the pH of this salt is going to be higher than 7. So pH greater than 7, that's all we know. We're not going to be able to know what it is, because it reacts with water to generate hydroxide ions. So the high concentration of hydroxide ions will be slightly greater than the concentration of hydrogen ions. Really, that's all it means. Okay. And then you can make exactly the same argument for a weak base, and that would usually be an amine, or typically ammonia. So if I take ammonia and react it with a strong acid, so weak base, and react it with a strong acid, the arm wrestle argument still holds really nicely. We generate NH4 plus Cl minus. That's called ammonium chloride. Remember, ammonium NH4 plus. Ammonium chloride. And this stuff is an acidic salt. You don't need to think about it. You can pick up the easy mark by just going, oh, strong versus weak, who's going to win? Okay, yeah. Tom Howard or Martin Green? Well, Tom Howard's going to win every time, right? In an arm wrestle. Get the idea? So how do you explain that, though? Exactly the same argument. You can write this in two ways, though. If you take that ion, that acidic ion, and chuck it in to water, you're going to generate the thing that gives you a pH of less than 7, aren't you? Which, well, I should draw this as an equilibrium, really, shouldn't I? Which is H3O plus NH3. Again, I am regenerating that, but it's not that makes the pH difference, is it? It's that stuff. Or to keep it simple, you might just want to write it out, a simple dissociation of that weak acid into H plus and NH3. So even though it's a very, very weak acid, it is enough of a weak acid to make the hydrogen ion or H3O plus ion concentration greater than that of the hydroxide ion concentration from the dissociation of water, meaning the pH is less than 7. That, folks, is it. I'll take any questions at that point. So that, I think when you hear it explained for the first time, it's really not that complicated, but can you recite that in an exam? Can you get that argument across in an exam? Would be with a challenge I give you. Quite often we explain things well, but can you explain them back perfectly? If there's no questions, I'll stop the video and you can watch it back later if you want to. Any questions at all? I'll stop this, I'll share it with you guys and your colleagues.